What's up, guys? I'm Chad Barnes, and welcome to the channel. Here, it's all about real car talk, from simple fixes to smart driving tips and keeping your ride in top shape. If that sounds good to you, go ahead and give the video a thumbs up. Hit that subscribe button, and make sure you watch all the way through. There's a lot of good stuff coming. Let's get to it.
Here we reduce here. So, what is the purpose of this regulator? This is what it is needed for, to regulate the pressure in the fuel ramp and hence in the injectors. The reason for this necessity is obvious. In different modes of engine operation, under different load and with different revolutions, the amount of fuel consumed is also different. And if the air is controlled by the throttle, it is a bit more difficult to regulate the gasoline supply. You can, of course, change the time of operation of injectors, but it is not enough. You need to change the pressure in them. Otherwise it will not be possible to adhere to the proportions of stoichiometric mixture 14.7:1. At idle speeds the pressure should be lower, at high speeds, when the fuel-air mixture flow rate is higher, and the pressure should be higher. How can this be arranged if the pressure that the gasoline pump creates is always the same? To start with, the gas pump is a powerful guy, and it has a lot more potential than it looks. A new gasoline pump generates a much higher pressure than required. It is understandable, over time, filters will clog, and some pumps have a non-replaceable filter, injectors and fuel line may get dirty. Therefore, initially the pump pumps more pressure than required. Excess of this pressure is not terrible at all. It is possible to make a valve, which would discharge excess pressure into some return line, from where this excess fuel would be returned to the tank. Everything seems to be simple, and such a simple valve could become a pressure regulator, but a very important issue with pressure regulation depending on the revolutions remains unsolved. And where can we get the pressure that would inform such a valve about the engine RPM? Of course, in the intake manifold, the more rarefaction there is, the lower the RPM. This dependence can be used in the pressure regulator. And the result is a very elegant design, which in essence is a diaphragm valve. But if on one side the diaphragm is pressurized by fuel, which is quite logical, then on the other side there is another force besides. The spring vacuum of the intake manifold. That is why the pressure regulator is approached not only by fuel pipes, but also by a vacuum tube from the manifold. And this system works as follows. At low speeds, the strong vacuum stretches the spring, the diaphragm is easily deflected by the gasoline pressure, the shut-off valve is opened and allows gasoline to flow safely into the return line. Once the RPM starts to rise, the rarefaction in the manifold becomes weaker and vacuum can no longer effectively prevent the spring from pushing on the diaphragm. Fuel needs more pressure to overcome the resistance of the spring and open the shut-off valve. This means there is more of it. Less gasoline flows into the return and more gasoline flows into the injectors. Thus the regulator maintains approximately constant fuel pressure in the ramp. It is clear that it cannot do it absolutely accurately. The accuracy of a mechanical device is in any case less than what the engine control unit wants, but it is quite enough for the ECU to adjust the fuel correction within not too wide limits. Well, the fuel pressure regulator due to its simple design received the own name bypass or check valve. In fact, of course, it is not just a valve, but a rather tricky one, controlled by vacuum in the intake manifold. What could possibly go wrong? Despite the fact that the fuel dispenser is not too complicated, it can sometimes go wrong. Most often there is only one problem with it. If you regularly refuel your car from a puddle at the gas station, it will get clogged with all sorts of crap that should not be in normal gasoline. True, in this case more delicate injectors are more likely to suffer, but also the regulator has the right to rebel and, for example, to sour. In addition, some regulators have their own small filter mesh, which also gets clogged with deposits over time. As a result, the regulator starts to work either insufficiently accurately or stops working at all. What is it fraught with? Of course, it is fraught with violation of fuel mixture composition, which can become either too rich at idle speeds or poor at high speeds. The symptoms of malfunction are very diverse. There can be black exhaust from the pipe and a decrease in traction and, accordingly, dynamics and overheating to caliber ignition. In general, there are many consequences and not everyone can suspect the pressure regulator in all this ugliness. Of course, the ECU tries to correct the situation. By the signal from the control lambda sensor, the unit sees that there is something wrong with the mixture. For example, there is too much oxygen in it, which indicates a shortage of gasoline. The ECU tries to increase the injector injection time, but alas, no matter how long the injectors try to inject gasoline, there is nothing to inject, simply not enough pressure. Sometimes at this stage the fuel pump is under suspicion, they say, it does not cope with its tasks. And indeed, if you connect a pressure gauge to the ramp at this moment, it may seem that the pump is malfunctioning, the pressure will be low. But how can it be normal there if the jammed RDT decided to let everything that it can at once to the return line? Another characteristic symptom of the valve jammed in the open position is poor starting of the engine after parking. A serviceable regulator allows keeping high pressure in the fuel line for a long time. A defective, frozen in the open position, RDT cannot do this, as a result of which the injectors have time to breathe air. The engine has to be cranked with the starter longer than usual to get all the air out of the fuel ramp and to build up gasoline pressure there. If the valve is jammed in the reverse position, locked, one of the signs of this malfunction will be flooded spark plugs when starting the engine. Excess gasoline cannot escape into the return, the pressure in the ramp is increased, and the injectors at idle speed pour much more than it is required. As you can see, it is difficult to suspect one small detail in such opposite problems. But fortunately, it is quite easy to check. Since the degree of valve opening depends solely on the manifold vacuum, it is enough to remove this single control signal and see how the character of the motor operation changes. In other words, it will be enough to start the engine and disconnect the vacuum tube from the RDT at idle speed. Since the regulator will no longer see the vacuum, it will think that the revs have risen sharply and there will be nothing left for it but to maximize the pressure. This will immediately change the character of the engine operation. At first the RPM will increase, then there will be signs of operation. On rich mixture, for example, increased smokiness. If there are changes, the regulator can be recognized as conditionally serviceable. If there is no reaction to removing the tube, it is definitely dead. The regulator can be recognized as absolutely and not conditionally serviceable only after checking the fuel pressure in the ramp with a manometer. If the pressure remains normal when the crankshaft RPM changes in a wide range, the fuel regulator is serviceable. If not, it does not work. This method of checking is more accurate, but not everyone has a suitable manometer at home and in the suffering soul, the desire to connect it somewhere. So, for quick, but quite sufficient at the first stage of diagnostics, the simpler first method with disconnection of the vacuum tube is suitable. What to do? Theoretically, it is not accepted to repair the fuel pressure regulator, it is simply replaced. Usually it is not too expensive and its resource is high, so it has always been easier to buy a new one, quickly replace it and enjoy life for many tens, usually even hundreds of thousands of kilometers. But if you have difficulties in finding spare parts or their cost, you can remember that the regulator can be helped by a good cleaning. If it does not help, it will have to be replaced. You can clean it any way you want. If it has a clogged filter screen, some carb cleaner will help. If it is completely dirty, you can use an ultrasonic bath or any other methods, but, unfortunately, there is not much chance that all this will help it. Maybe the valve itself has already worn out, or maybe the diaphragm. No cleaning can save it, and in some cases it can kill the RDT finally. For example, if too aggressive chemistry squashes the already half-dead diaphragm. In general, if there are problems with the pressure regulator, it is better to accept the necessity to buy a new part. It will be much easier and more reliable than a dubious repair. In conclusion, understanding the role of a fuel pressure regulator is essential for maintaining optimal engine performance. By ensuring that your fuel system operates at the correct pressure, you can enhance efficiency, improve throttle response, and prevent potential engine damage. Regularly checking your fuel pressure regulator can save you time and money in the long run. Remember, a well-functioning fuel system is a key component of a reliable vehicle. Thank you for watching and be sure to subscribe for more insights on automotive maintenance.